The normal distribution is the most widely used distribution in statistics. It's a theoretical construct, meaning that it doesn't exactly describe anything. However, many scientists have found that there are lots of natural phenomena whose outcomes approximate a normal distribution. Since it's a probability distribution, the area under the curve is exactly 1, just like it is for any probability distribution. Because it describes the probability of a continuous random variable, we know that the probability of any single event is approximately 0. But if we sum up all of the infinitesimally small probabilities for all of the infinite possibilities, we would get 1. If you're a calculus person, it means that the probability distribution function integrates to 1 over the support of x, which in this case is from -infinity to +infinity. If talking about integrals makes you sad, just forget we said anything about it at all. Probability density functions describe how to calculate probabilities for a continuous random variable. We won't belabor the equations here, but we need to understand that they exist and we can use them to calculate probabilities if we need to. There are lots of different kinds of probability distributions. We'll look at several of them over the time we're together as they become useful to us. There are lots of attributes that we can use to describe what distributions look like. The first one we'll talk about is whether it's symmetric or skewed. A symmetric distribution is one that we could fold in half vertically, and we would find that the two halves look the same. That is, the shape on the right side is a mirror image of the shape on the left side of the vertical line that splits the distribution in half. There are two kinds of skewed distributions. Positively skewed ones, or ones we would call right skewed, are those that have a longer tail pointing in the positive direction. Negatively skewed distributions have a longer tail pointing in the negative direction. We can also talk about the modality of a distribution, or less technically, how many humps there are in the distribution. A unimodal distribution is one that has a single hump. As we'll see later on, the mode of a distribution is the most common value. Having a single mode means there is only one point on x that is most common. A bimodal distribution is one that has two separated peaks or humps. In this distribution, there are two different locations of roughly equally high density. A couple of examples are adult heights, which are bimodally distributed with peaks at the average height for men and women. Also, peak restaurant hours are bimodally distributed around lunch and dinner times. Any distribution that has more than two humps we call multimodal. Foreign direct investment is a multimodal distribution. There's a hump at 0 for those not giving or receiving aid, a hump at the mean of outflows for those aid donors, and a hump at the mean of inflows for aid recipients. The normal distribution we could describe as unimodal and symmetric. There are lots of unimodal symmetric distributions, and the normal distribution is a particular kind of distribution that is unimodal and symmetric. The chapter talks a bit about the central limit theorem. This is fundamentally important, but we'll come back to it in more detail after we discuss measures of spread and center. What the central limit theorem says is that if the number of trials is sufficiently large and the number of experiments is sufficiently large, then the average outcomes of all experiments will tend to look like a normal distribution.